Here are two more circle theorems to think about. The first one I like to call the Star Trek theorem. Oops, that's a terrible circle. Let's draw that again. If I were to draw an angle subtending from this chord, I'm going to do it as a dotted line. I'm going to do the rest of it in a different colour. Let's choose pink. So any sort of angle coming from here, it doesn't have to be here. I could have done it to this point here or this point here. So that angle at the top, interestingly, I'll do this in a different colour now. Let's do blue. Is half of the angle you would get if you subtended the from the chord to the centre. So this blue angle is double the pink angle. So if I went back to my, let's call this 2x. Therefore, in pink, that is x. And this is the Star Trek theorem because it sort of looks a little bit like that sort of Star Trek symbol that they wear. But it doesn't have to look like this. It could look more like the one with B. And if you were to draw this angle here, and you instead of doing it at this point, you did it at this point here, both A and B are equal. This is another circle theorem. So you can write that more technically as angles subtending from a chord are equal. So this is quite a good phrase to use. So angles subtending from a chord are equal. In other words, A and B are equal because they subtend from the chord PQ. But the Star Trek theorem, that could be written like this. An angle subtending from a chord to the circumference so that could be A or B, is a half of the angle subtending from, that should be a 2, subtending to the centre. So that would be the angle here. So there are two circle theorems to remember. The Star Trek one is the top one, and the double angle one is the second one there. Now another interesting one here is what's called a cyclic quadrilateral. That's spelt this way: cyclic quadrilateral. And you can spot, well, you may not be able to spot this. It's quite interesting to note that these two angles add up to 180 degrees. And it's the same with B and D, they add up to 180 degrees as well. But the points have to lie on the circle all the way around. If A, B, C, and D don't lie on the circumference, it's not called cyclic quadrilateral. Each one of those 4 points has to lie on the circumference. If that is the case, you can say that opposite angles of a cyclic quadrilateral add up to 180 degrees. So we've got 3 different circle theorems there to think about, and let's have a look at a worked example to put this into sense. Now the centre of the circle is here, and that hasn't really had any relevance to the shape inside the circle. All it tells you is that this line is not a diameter because it doesn't go through the centre. But it's not really important anyway. It's missing the invisible line, and that tells you that 35 and A subtend from the same dotted line. They subtend from the same chord, and that means that they are equal. So A must be 35 degrees. In B, we can see our Star Trek lopsided a little bit. If that's 25 degrees, then A is 50 degrees. And B, for the same reason that I mentioned in part A, that subtends from the same invisible dotted line. So B must be 25 degrees. Okay,